Other crop diseases. The majority of crop diseases are caused by fungi, bacteria, or viruses. Some diseases are caused by pests themselves or pests serving as disease vectors. These will be reviewed in the next unit. Other diseases are caused by pathogens that do not fall into those categories. These include oomycetes or water molds, as shown in the image below, that cause black pod disease, root and crown rot, damping off diseases, and downy mildew diseases, and nematodes or roundworms that cause root knot. Black pod disease. Black pod disease is caused by oomycete protists Phytophthora palmivora and Phytophthora megakarya. The Phytophthora species impact cocoa trees by destroying the cocoa bean harvest and causing premature tree death. Cocoa plants infected by black pod disease can be recognized by symptoms below, as shown in the cocoa pods in the image on the right. The rotting of cocoa beans within ripened seed pods and the rotting of redundant seed pods. Black pod disease is spread by zoospores. It multiplies rapidly during the wet season, especially as a result of rain splashing on mud. The cocoa pods indicated by the white arrow on the left have been infected by black pod disease. Cocoa trees are the plants most often impacted by black pod disease. Treatment of black pod disease include picking seed pods as soon as they ripen, picking redundant seed pods that will not develop, and leaving leaf litter on the ground to prevent zoospores from traveling via water and mud. Phytophthora parasitica and Phytophthora nicotianae thrive on dozens of hosts. You may encounter this oomycete or water mold impacting the root systems of plants such as tomatoes and tobacco. The root damage caused by Phytophthora parasitica also results in above-ground crown symptoms. Although symptoms vary, they include wilted leaves, discolored leaves like a dull green, yellow, red, or purple, darkened bark, red-brown streaks or zones below the bark, and gum or dark sap. Root and crown rot is caused by a soil-borne pathogen that flourishes in moist environments. A lack of proper water drainage, common soil, or unclean tools can transmit root and crown rot. The crops most impacted by crown and root rot are squash, tomatoes, tobacco, known as black shank in tobacco plants, citrus and banana trees, although there are many additional crops that may be affected. Treatment of root and crown rot includes fumigation and/or agrochemical application of fungicides, proliferation using resistant stock, and irrigation management. Damping off diseases. Damping off diseases attack seedlings. This disease is usually caused by soil and seed-borne oomycetes of the genus Pythium, including Pythium dibarianum and Pythium ultimum. Some pathogenic species from Rhizoctonia, Fusarium, and Phytophthora, also the cause of crown and root rot, also cause damping off. Oomycetes that cause damping off exist in most soils. It is especially prevalent in cool and moist environments, although can grow in drier and hotter climates as well. Damping off can be recognized by its symptoms: failure to germinate or take root or to survive germination and transplant. In pre-germination, the oomycetes usually prevent the seedling from growing above ground by causing poor strands and stunted or absent roots and/or the white mold-like growths at the soil level. In infection post-germination, the roots are stunted and the plant's stem becomes rotted, causing collapse. Damping off impacts seedlings of many different plant species, including most vegetables and flowers. The seedlings of the following species are most likely to be impacted by damping off: cowpeas, tomatoes, potatoes, peppers, okra, cashews, tobacco, and soybeans, as pictured. As with other soil-borne diseases, prevention is necessary to control damping off infections. This includes seed or soil treatment prior to germination and planting, proper drainage and appropriate water levels, sanitizing tools and maintaining proper hygiene techniques to prevent transferring infection, use of resistant species strands and elimination of infected seedlings, ensuring that seedlings have good air circulation, light, and distance from other seedlings, timing planting to avoid the cold and wet months. Downy mildew diseases. Downy mildew diseases are caused by the oomycetes of Peronospiralis. Two downy mildew diseases that impact Nigerian crops are caused by Peronospora destructor and Sclerospora graminicola. Downy mildew diseases can be recognized from afar by circular groupings of yellowed or yellowing plants. When infected, the leaves of an individual plant turn pale green, then tan to brown or yellow. Lesions on infected plants may become violet or purple. Leaves may roll or fold on themselves. Its name, downy mildew, references the furry gray-white growths developed before plant collapse and death. Downy mildew may cause systemic infection symptoms, impacting the seed stalks, bulbs, and flowering parts of the plant, and causing soft rot. Peronospora destructor infects species in the genus Allium, most commonly onions and shallots. The infection can occur in leeks, garlic, and chives. Peronospora destructor thrives in cool but highly humid temperatures. It only grows and reproduces in live plants, but can survive in soil and leaf debris. Spores are airborne and require wet leaves to infect a plant. Sclerospora graminicola exhibits the same symptoms as Peronospora destructor, but its furry growths are larger due to the massive reproduction of its zoospores. Sclerospora graminicola impacts corn and millets, both foxtail and pearl, but each species has its own pathogen. Although there are agrochemicals that can treat downy mildew, prevention is critical. Prevention of these diseases includes agrochemical application, seed or soil treatment prior to germination and planting, proper drainage and appropriate water levels, sanitizing tools and maintaining proper hygiene techniques to prevent transferring infection, and use of resistant plant seeds. Root knot. Most vegetables are susceptible to root knot caused by nematodes. The nematodes, or parasitic roundworms that cause root knot, include Melodogene hapla and Melodogene incognita. They thrive in warm climates with short winters. Melodogene species live in the soil, entering a plant as larvae through the roots as seen in the image at right. The larvae exit through the galls in a mass as shown by the bubble-like growths in the bottom photo. The root knots formed are built around nematodes and their eggs. Thousands of species of crops are susceptible to Melodogene species, which can cause significant global crop losses. Each crop responds differently to infection, and there are few above-ground symptoms. However, you may notice plants that have stunted growth, fail to thrive, wilt, yellow, and/or produce fewer or smaller fruits. The root galls growths indicate infection, but it can only be officially determined with soil sampling and examination under a microscope. Proper hygiene and protective gear should be especially followed if root knot is suspected. Prevention and treatment of root knot is similar to other soil-borne diseases, including maintaining proper irrigation and nutrient levels, crop rotation, tool sanitation and hygiene, soil and seed treatment, planting resistant varieties, and nematicide application. The following slides have a detailed review of the other crop diseases we've discussed. I'm not going to go through each bullet point one by one because we've discussed these in detail in the previous slides, but I want to call your attention to what is here for your review. Each of the diseases' common names, like black pod disease or damping off diseases, their scientific names, the symptoms, spread, the Nigerian crops most impacted, and treatment of those diseases. Other crop diseases we've discussed are crown and root rot and downy mildew diseases. The other crop diseases discussed in the previous slides were all caused by oomycetes. The one caused by nematodes is root knot.